This video shows another way to do the 3D problem of flow in a circular aquifer. So we're going to add the 3D geometry as a cylinder with a 1,000-meter radius and a 10-meter height. We're going to put another cylinder in with a 0.1-meter radius and a 10-meter height. This will be the well bore. And we see that right now we have two cylinders. They're two concentric solid cylinders, but we're going to use the Boolean expression difference to subtract the inner cylinder from the outer cylinder. And when we do that, we get a hole. And that hole will be the well bore. So we're going to go and set up the physics with Darcy's law. Import the variables using the file like we have in the other simulations, and then add the boundary conditions. We've got a pressure boundary condition on the inside and a flow boundary condition on the outside. So here's the pressure boundary condition. We've got to make sure to hit all four of the outer sides. They're kind of thin in this model, so we've got to select all of them, and we see all four sides there that have been selected. And then for the inlet, we have to do the same thing. We have to zoom in on this small hole, and we have to select all four of the inner sides of that hole, kind of rotate back and get that last one. There's four, and then we're going to specify the flux as well flux, and I'm going to specify the density of the fluid and the dynamic viscosity, porosity of 0.1, and we've got to make sure to set the hydraulic conductivity, and we're going to use the variable K that we've already set up as shown in the previous videos. We'll just use a default mesh for this, so we just set that up and we add another study. We only want to run the last physics, the Darcy Law 4 physics. We've got all four of the simulations in this model. And so we run it and take a look at the results. And we're going to use a cut line. So we had a cut line from the previous model, the previous 3D model that we saw in the other videos. So we're just going to change the data set that we used to study for data set. And then we're going to plot that on this this plot that's semi-log that's showing the pressures as a function of radial distance, and that blue line is the new one with the 3D plot. And now we see some 3D plots of the, first of all, the pressure, and we're going to change it to hydraulic head. So the problem is symmetric, so we can see the symmetric color distribution. Want to visualize this a little bit better, so we're going to put some deformation that is going with the hydraulic head, and you can see that little dimple in the center, and we're going to amplify that, and you can see now there's basically the whole model is being deformed by an amount that's proportional to the hydraulic head. Another way to show data sets like this is with contours. You can see the contours there in red. That's the default color, but it's hard to see superimposed on the color flood. So we drop off the color flood, and you can see the contours in there now. We can show the contours along with the color flood. It shows up a little bit better if we change the color. So there's white contours on the color flood. And if we wanted to include the deformation, we see that setting up the deformation like that deforms the color flood, but not the contours. But we can also deform the contours if we like. So we put on the hydraulic head as the Z component of the deformation. And now we have to get the scale factor to be the same in the two plots. So we're just going to set it to 100 in both. And now this should give us the contours on the color flood surface.